Hi guys. We are continuing with section 10-2, but there's multiple parts to this section. So today we're going to start focusing on what happens when you have square roots in a fraction. We will be spreading this concept of fractional square roots across 3 days so we fully understand it. Before we start working on fractions, I want to go over the basic mental space that you need to be in when you're doing a fraction problem, a division problem. So there's a list of questions that you should ask yourself, and they are in a very specific order so that you can get to your answer the fastest way possible. So that we are not wasting time doing extra steps that we don't need to do and getting lost and going in circles. And we're just trying to kind of streamline the process to simplifying our fraction. The first thing that you need to know is that when we have a fraction with a square root in it, it's not allowed to have a square root underneath the fraction bar. You're not allowed to divide by a square root. This is kind of like a math grammar thing, kind of like, in English class, you have to put a period at the end of the sentence. In math class, you can't have a final answer where there's a square root under a fraction bar. You also should not have a square root symbol completely surrounding a fraction bar. The only appropriate place to have a square root symbol when you're doing a fraction is just on the top of it. So to help us get to the answer in the most streamlined way possible, we're going to ask ourselves 4 questions. So the first question is, do I see any perfect squares in this problem? If you see a perfect square, you can square root it right away, right? Like if I see the square root of 64, I'm like, oh, I know that. That's 8. So if you see any perfect squares, go ahead and square root those right away. If there aren't any perfect squares, then you want to ask yourself, can I simplify my fraction? Maybe you have a fraction that's an 8 divided by a 2. Well, I can divide that. That's 4. So we're going to try to simplify the fraction. Now, you're only allowed to simplify the numbers if they are either both under a radical or both not under a radical. You can't simplify an outside number with an inside number. So they need to be in the same position. Next, try to do a factor tree. See if you can get a pair of prime numbers, right? So maybe you have the square root of 8, and that turns into 2 times 2 times 2, so you get a pair of 2's. So do your factor trees and see if you can get a pair of numbers. When you get pairs of numbers, they have to be either paired up on top of the fraction bar or under the fraction bar. You can't pair up a top number with a bottom number, but you can cancel a top number with a bottom number. Hopefully you had already done that. Now, if you've gone through all 3 of these steps and you've simplified as much as you can, you found as many pairs as you can, you did everything you can possibly think of, and there's still a square root sign under your fraction bar, then we need to do a process that's called rationalizing the denominator. Now, we're going to leave this process for tomorrow. Today, we will be able to get to our final answer using just the first 3 steps. So tomorrow's video and Friday's video, I'm going to really focus on how to rationalize a denominator. But for today, we're going to focus on these first 3 steps. So let's try a problem. All right, so here I have the square root of a fraction, and we said that's not allowed in math class. In this problem, it does not help me to keep the fraction all under one radical symbol. Because I cannot simplify my fraction, 34 and 25, those can't simplify. So my first step on this problem, I'm going to split this into 2 separate radicals, a top radical and a bottom radical. Now maybe you've noticed something, and maybe you didn't. If you didn't notice something right now, then your next step would be to factor tree each individual number. 34 can split into 2 and 7, and 25 can split into 5 and 5. Now you should notice that the bottom was a perfect square. On the bottom, we have this pair of fives. So 1 5 is going to go out here. Now, when the 5 goes on the outside, it's outside the radical, but it still needs to be under the fraction bar. So don't let it like magically float to the top. Keep it under your fraction bar. This 5 is poof, gone. Now on top, I did not have a pair of numbers. 2 and 17 is not a pair, but you do have to check. If you have a pair of numbers on top and you didn't check, then you're going to get the wrong answer. Since there's no pair of numbers on top, I'm going to go ahead and multiply those back together to the 34, and it's going to still be under the radical. And on the bottom, I've got a regular number 5 that is not under the radical. Now that my denominator is not under a radical, and I decided that I cannot simplify my numerator, I can say that this is my final answer. Please notice that the square root symbol is completely contained above the fraction bar. You don't want to write a problem where you accidentally make the square root go below the fraction bar. Okay, this would be bad because that square root symbol dipped down below. So make sure it's completely above. All right, let's try one more together. In this problem, again, I have a square root below the fraction bar, which is not allowed in math class. Now, in this problem, I noticed that 56 is divisible by 7. So unlike our first problem, in this problem, it actually would be good for me to put the entire fraction under one square root. That way I can simplify 56 divided by 7. 56 divided by 7 is 8. And so now I can change this to just the square root of 8. Now don't be fooled. We no longer have a fraction, which means we definitely don't have a square root under the fraction, but I can simplify this some more. So just because the fraction is gone does not mean that the problem is answered. I'm going to factor tree my 8. 8 turns into 2 times 2 times 2. Here I have my pair of 2's. And so my final answer is 2 times the square root of 2. So again, make sure that you keep going until you cannot simplify anything else. Before I release you for your homework time, why don't you try these two, and then we'll check our answers. And if you get these two correct, then you should be ready to start your homework. So pause the video, and when you're done, check back in. All right, let's check and see how you did. So for my first answer, I got the number 2. If you need to see work, I did my work on my whiteboard. So I started by splitting the outside numbers and the inside numbers into 2 separate fractions. I am allowed to simplify numbers that are both on the outside. So you can see I simplified my 8 divided by 2, and that became this 4 right here. And then you can also simplify the numbers on the inside. 2 over 8, that simplifies to 1 over 4. Now, both 1 and 4 are perfect squares. We can square root them. The square root of 1 is 1, and the square root of 4 is 2. And since I square rooted both numbers, I now no longer have the square root symbol. And 4 times 1/2 is 2. So that's the work for number 1. All right. It's okay if you didn't get number 1 right. Maybe you got number 2 right. So let's check our answer for number 2. I got 6 times the square root of 3. Again, on this problem, you were able to simplify your fraction. 324 is divisible by 3. It turns into 108. Next, I factor treed the 108, and here's my prime factorization. We've been practicing this during our live classes. I had a pair of twos and a pair of threes, which became this six out here. And then I had one three left over. On tonight's homework, you should be able to get rid of the rad under the fraction bar by just simplifying the fraction, or maybe the number on the bottom is a perfect square, so you can just straight up square root it. Tomorrow, we will talk about what to do if you can't get rid of the radical under the fraction bar. I'll see you then.